what we have today. Yesterday, I told you it's a parallelogram. I told you the 5 properties to it. Today, we're going to prove, don't worry, we're not writing proofs. You're going to prove to me, or show me, or explain to me why it is a parallelogram off some given information. But before we get to that, let's just first practice using our 5 different properties we learned yesterday. Find the following tells you it's a parallelogram. Okay, well, let's just go in order. Let's not overthink it. What's AD? 12. Because remember, opposite sides congruent. Bless you. Okay, next up I'm going to do BD. So, of course, here we go. So, BD, this whole diagonal. Well, diagonals. One property about diagonals. Diagonals what? Bisect. So, if this guy's 5, this guy is 5. So, what's the whole length of BD? 10. I like when we hardly have to do any work. Okay, measure of A, and I kind of chopped the corner off there, B, D. Okay. So we have to do a little bit of figuring here now, okay? So we're looking at the angles. So the first thing I'm thinking about, you have these consecutive angles. What do consecutive angles add up to? 180. So you've got 120 here, so I know this whole corner needs to be 60 to make the 180. Now, we're going to be smart here. If they tell you this little side's 40, what's this little side going to be to get you to the 60? 20. I'm going to write a really tiny 20 in there, and I'm going to write 20 over here. So we have to do, you know, a little bit of calculation there, a little bit of figuring. Not too bad, though. All right, we're on 4. C, D, A. So the corner. Love it. I don't have to overthink it. Opposite angles are what? Congruent. So if that whole corner, I'm using the whole corner of 60, I know this whole corner is 60. Okay, last one. Measure of B, C, D. So the purple one, well, that's easy because opposite angles are congruent. So no work needed. What's your final answer? 120. Love this stuff. Kind of like a puzzle. Okay, any questions on that? Now, as you can see, yes, there is a lot of writing you're going to do on your notes here, and you know I can't help myself. I'm going to add some things to it. So, okay, before we get into writing, this isn't on your notes. We're just going to read it and talk about it. So our properties of parallelograms from yesterday, we just reviewed those. We know what shapes a parallelogram. You have those 5 properties. Today, this is just yesterday. This is straight off of yesterday. These are our 5 properties that we reviewed and just practiced on the warm-up problem. Opposite sides congruent. Opposite angles congruent. Consecutive angles supplementary. I feel like I've read this a million times. Diagonals bisect. Okay, we got it. So now what we're going to do is how to show that it is an actual parallelogram. I don't know it. We're going to show it. So one way to do it. Yes, you got it right. I know. Show both pairs of opposite sides are parallel. Now I'm going to add to this because you know I can't help myself. So what does that mean, parallel? We saw it in one of yesterday's problems. On a graph grid, parallel lines have the same slope. So there's 5 different ways to do this. I kind of like number 1 because I don't think it's too bad as far as work. But you do have to count 4 slopes. Is what that means. So I would have to count rise over run on the left and right side and show they're the same. Rise over run top and bottom, show they're the same. I mean, that's not that hard, but still I got to do it. Okay, I don't like number 2. Both pairs of opposite sides are congruent. If I want to show these are the same length, this is a bad one. I try to avoid this one like the plague because you have to do 4 distance formulas. Ooh. Yep. So I'm going to be honest, I kind of avoid number 2 if I can, because just calculating 4 distance formulas is pretty dang time consuming. Okay, both pair of opposite angles are congruent, so they might just give you that information, so that might be an easy one. We just have to see what they give you. So far, I mean, my favorite ones are number 1. Put a little star by that guy. I like that one. I avoid 2 like the plague. Sometimes 3, they'll tell you those opposite angles are congruent, so that's kind of a win. 4 isn't too bad, but I really like 5. 4, show 1 pair of opposite sides congruent and parallel. So congruent means, of course, I don't love it, distance formula. And distance formula is time consuming. And of course, parallel would be slope. That's not bad. So 4 is like, I try not to use it because of distance formula, but it's not an awful pick. I really like 5. And I know you're still writing, so I'm going to wait a second. I don't want to get too, I know, this is the most writing you got to do today. So I really try to lean towards one, unless you have a love a distance formula, I guess. I don't want to sway you off a distance formula, but if you really love it, I mean, I guess do it, but I really don't love it all that much. I like number 5 a lot. I'm going to start this one. Now here's why I like this one, okay? Because, you know, I'm trying to work smarter, not harder here. I'm trying to do the least amount of work, right? Bisect each other. Remember, bisect means they hit in the middle, midpoint. So for bisect, for diagonals bisect each other, you could just do the midpoint formula, which that to me is pretty simple. That's why we've kind of been practicing it. So if I have a choice, okay, I can do it however I want to do it. I lean towards the very top one, because I can count slope pretty quick, I'm pretty good at it, or I'll do the bottom one. I'll show that the midpoint on both diagonals, so you got to calculate the midpoint formula of one diagonal, the midpoint formula of the second one. So you need to do it twice for each diagonal. So those are the least amount of calculations. You can do it, and you'll see there's going to be one problem where we get to pick how we want to show that it's a parallelogram. I would either do the top thing, all the slopes, or midpoint. I'm going to show you both. If you have a love a distance formula, I go through this one formula, but I'm not sure anybody has a love a distance formula in here. Now notice one thing that's different. One thing, and that's that star down there. We gotta fill in the star, okay? One thing that is missing, so to speak, on our list. Remember, one of the properties of a parallelogram is your consecutive interior angles are supplementary. That is not a way to show that they are a parallelogram. So consecutive, I wouldn't get crazy and write all of this. I would just say consecutive angles, not a way. So no consecutive angles. You could just write that if you wanted. Short and sweet, like me. So many words. We haven't even done anything yet. They're going to give you some pictures and ask you if there's enough info to show it's a parallelogram. So many words. Now, a lot of words on the next page, but notice at the top there's nothing for you to fill in. We're just going to look at those. I just see people writing, so I'm just going to wait a second. Love it. I almost misproofs. Okay, let's do it. So again, just rest your hand here for a second. Let's just take a look at this. So again, in your mind, two different trains of thought. If you know it's a parallelogram, you know it. So it's those 5 properties I showed you yesterday. Opposite sides congruent, opposite angles congruent, consecutive supplement, diagonals bisect, opposite sides parallel, are 5 properties from yesterday. If I have to show it, no consecutive interior angles over here, notice, no consecutive interior angles is on this. And here's the difference. You're like, well, there's 5 there, there's 5 here. So no consecutive interior angles because there's this one, that number 4. Show one pair opposite sides are parallel and congruent. That's taking the place of those consecutive interior angles. So there's still 5 and 5. And this is just, I mean, it's on your sheet. It's the same thing we just talked about. That I just rambled on about. No consecutive interior angles. Okay, enough drama. Let's look at it. Is the quadrilateral a parallelogram? Well, what's the only thing they have marked on there? Opposite sides are what? Congruent. I have one pair, only one, top and bottom, not left and right. One pair opposite sides congruent. Is that on our list? One pair opposite sides congruent. Is that anywhere on this list? No, so we don't have enough information. So I'm going to say, click it back, not enough info. probably should say no for like a final answer there too. So if they told me those sides were also parallel, then we'd be in business. I could say yes, but they didn't. Okay, let's look at B. So let's just analyze the picture. I'm looking at those angles. Remember, consecutive doesn't count, so don't even think about consecutives. What do you notice about the opposite angles? Ooh, is that one of our ways? Yeah, show that both pairs of, that's number 3. Show that both pairs of opposite angles are congruent. So I'm going to say yes. When I get over here, and I'm going to say both pairs, because it wants an explanation. Opposite angles congruent. So that was number 3 on your list. All right, let's look at, this is an interesting little word problem here. Are we ready? Okay. And it's super tiny on your paper, I know. An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. This is why I don't ride rides at the fair. Okay, I'd be sick. In the diagram, AD and BC represent 2 of the swinging arms. Okay, all right, I see AD, the left, and BC, the right. That's great, okay. DC is parallel to the ground line, okay. Explain why the moving platform represented by AB is always parallel to the ground. Boy, that's a lot, okay. So it says, let's take a look at this. AB and BC are 2 of the arms. DC is parallel to the ground. So DC, you can see, just to point it out, to the ground. So hopefully you can see those little triangles on there for the parallel. So here is the question. Explain why the moving platform, this quadrilateral, is always parallel to the ground. Okay, well here's why. This is a throwback to first semester. Because of course, if these 2 are parallel, this one is going to be parallel also. So I'm going to add that triangle on there. This is a throwback. I don't know if you remember this property. Transitive, there's a good word, property of parallel lines. That's all that is. So of course they're all parallel to each other. That's all it is. Don't get carried away about that. That's just kind of a fun one to look at. The next page is what you're really going to focus on for your homework. For what values of x and y is a quadrilateral parallelogram? So we don't actually know it's a parallelogram. We're going to make it be so by solving for x and y. So I find some x's here. Now I know there's x on this one. Notice I circled the top and bottom. For it to be a parallelogram, yes, these sides need to be parallel, but they also need to be what? Congruent. So I'm just going to do x plus 9 equals 2x minus 1. All right, let's solve that. I'm going to get x on the same side. You guys can probably just do this a lot in your head. What's your final answer for x? 10. Well, that was easy. I like that. Okay, let's do y. So of course I see y, and I know this side. I know these guys are congruent. Well, I mean, it's still easy, but we got to do a little substitution here. So I know y is going to equal that x plus 7. And again, I don't love the variables, but you just figured out what the old x was. Put a 10 in there. Add it up. What's 10 plus 7? 17. Got it. So this is the style of questions you're going to see more so on your homework. Oh gosh, I'm going to have to draw a picture here. Let's get excited. In quadrilateral, WXYZ, W is 42, X is 130, okay, find Z. Is it a parallel? Okay, let me read it. So first off, I would probably draw a picture here. So I'm going to kind of just draw like a generic parallelogram. Don't judge my art skills. Now, label it. You can start labeling on any vertex that you want. You can start W here, whatever. I'm going to start it here. And I'm just going to go around. X, Y, Z. Okay, I'm going to start filling in the stuff. W is 42. Angle X, 138. And angle Y, 42. Find the measure of Z. Is it a parallelogram? Okay, so let's do it. All right, so for this guy, of course, let's first start with what is angle Z. Now, here we go. Here's where this gets fun. I know you want to say it's what? What do you think Z is? 138. Because if here's where this is fun. If I know it is a parallelogram, I could slap down 138 and be done. But I don't know that yet. I don't know it yet. I'm trying to figure it out. So I'm going to use an old school formula up here on the board from 7.1 to do the work to prove it is actually 138. So I'm going to use that interior angle formula. Of course, there's 4 sides. You know this. Mental math it, or just know it. 360, right? We know that. That's nothing exciting. So I'm going to find that angle like I did in the first section. I don't know it's a parallelogram yet. So in your calculator, what's 360 minus 42 minus 138 minus 42? Punch that in for me. Okay. Okay. So now I think we're getting somewhere. Now that I actually did the formula and calculated the 138, now do you have enough information to say it's a parallelogram? Yes, because now we do know that both sides, both opposite angles are congruent. So I'm going to say yes, it's a parallelogram. Both opposite angles congruent. That's OPP. Man, my handwriting's getting sloppy. Opposite pairs, angles, congruent. Okay. So you have to do a little, we're not writing proofs, I don't want to say the word proof, but you have to do the work to justify why it's 138. You can't just know it like you did yesterday. We don't know it's a parallelogram from the get-go. That is the difference. All right, doorway shown as part of the building has slowly leaned sideways, as you can see. Explain how you know that SV equals TU. Okay, well let's first have a little chit-chat-a-rooski. Is there enough info on this? Look close. I didn't copy the best. I'm focused in on these. I don't know how well you can see those. Do you have enough information to show, to know, to prove it's a parallelogram? So what do we know about, oh gosh.
Pardon the interruption?
Yes?
Do you have Gregory Smith in class?
I do.
Could you send him to the attendance office with his things, please? He'll be leaving.
Okay, hasta la vista, Greg. Okay, so look at your symbols. The triangle means parallel. Obviously the tick mark congruent. So I'm going to flash it back here, way back, way back. Do we have anything on this list to prove or justify and say, yes, it is a parallelogram? We have one pair of opposite sides congruent and parallel. So I heard somebody say it, number 4. So we have that information. So let me click it ahead. Keep going, still going. Okay, so first off, I'm going to say, yes, it is a parallelogram. Because we have the one pair, opposite sides, congruent and parallel. Okay. So now that you 100% know it's a parallelogram, do we of course know that SV and TU are going to be the same? Is that one of your properties of parallelograms? Yes. Because of course opposite sides congruent. That's for this part. So that's kind of the difference from yesterday. I do not a lot, don't freak out on me, but a little explaining on a couple of the problems on the homework. Now, of course, obnoxious problem, easy problem. For what values of x and y is a quadrilateral a parallelogram? Okay, you have diagonals. So what do we know about the diagonals? They have to do what to each other? Bisect. Okay, so look at the diagonals here. These have to bisect each other. They already told you the one did. They put the tick marks on it, so we already got that one. We need to make the other ones be equal. So they do, in fact, bisect each other. All right, just let's solve for x. I'm going to get the x's on the same side. I'll have 2x over here, 8, 0 on the right. Well, you can probably do that in your head. Add 8 divided by 2. What's your final answer? 4. Any questions on that? All right, home stretch. We got some yes or no ones here. Okay, for each determinant, the following gives enough information to conclude it is a parallelogram. Okay, all right. Both pairs, I like that word both pairs of opposite angles are congruent. Is that one of the ways to prove it's a parallelogram? Is that on your list? Sure is, yes. Okay. In quadrilateral MNOP, NO's 12, MP's 12, so we have congruent, 12 congruent, and they're parallel. Is that one of the ways to show that one set of sides is parallel and congruent? Yeah, I believe it's the third one. I'm going to stop I read the second word in 3 and I'm like, dude, I'm done reading. What can we not use? Consecutive angles. It's the one thing we can't use to prove it's a parallelogram. Okay, diagonals intersect at point M, which is, oh, okay, I like that, is the midpoint. Does midpoint show that they bisect each other, that they're cut in half? Yeah, sure does. I like 4. Let's go with a yes on that. I gotta scroll it down for 5. It's a square. Ooh, let's check the square. What do you know about a square? Hit me. Okay, so the sides are congruent. What do you know about the angles? How many degrees are they? 90. They're all 90 degrees. Is that enough info to say it's a parallelogram? I feel like I have more than enough info there because, of course, got a lot of ways you could do it. Opposite angles congruent. Yeah, the 90s. Opposite sides congruent. We got that one too. We got that one too. We got a lot of stuff on this one. So we don't have to explain. Let's just say yes. I love a square. Square has like all the properties that we ever go over. So that's kind of an easy one. All right, here we go. There we go. Okay. Show that the quadrilateral of those vertices is a parallelogram. Okay, you know the drill. Let's start plotting the points here. A is at -3, 3. Label, of course. B at 2, 5. C at 5, 2. And D at 0, 0. Okay. Very chance to plot them. Now you're finishing plotting the points. Now just really quick, let's go back to the list. Okay, so 5 different ways we can now show this. I'm going to avoid 2 like the plague because we don't want to do 4 rounds of distance formula. We don't really can do anything about the angles being congruent. I can't get you the measurements. I mean, I guess if I wanted to whip out a protractor and try to measure, I could. I don't love 4 because distance formula, and I do kind of like 5 because midpoint's pretty easy. So I'm going to show you, I'm going to do 2 ways you can take your poison on your homework. I'm going to start with the top one. I'm going to do the slopes of all the sides, and then I'm going to show you the bottom one, the diagonals bisect with the midpoint formula. And you can pick how you want to do it on the homework. I get back, too many slides here. So first things first, I'm just going to count the slopes, or you're going to count the slopes. Let's start at the top. What is the slope from A to B? So just count your rise over run. So up to, you count it, how many over are you? Okay, so 2 over 5. Just list it. Now count the slope of its opposite side. Do DC for me. So up to, over, how many? 5, shocker, right? So that's 1 pair. We need both. So now I'm going to do the left and right. So I need the left, AD. So from A to D, we got to go down 1, 2, 3, and right, how many? 3. So down 3, right 3. I'm going to simplify that. I'm going to put -1. Okay, do the right side for me, B to C. So from B to C, down 3, right 3. Shocking news there. So did I prove that it's a parallelogram? Did I show both pairs of opposite sides parallel? That is one of the quickest ways to do it, okay? I have some kids, that's one way. I'm just going to say or. You do not have to do both. I'm just going to show you another way. I have some kids that are like, man, I don't want to do 4 slopes, although I don't think it's that bad. You could do the diagonals bisect, meaning you could do the midpoint of DC. So D, of course, was 0, 0. C is at the 5, or sorry, B is at 2, 5. And I'm just going to midpoint formula those. 0 plus 2 over 2 Yes, I'm gonna make it a 1. 0 plus 5 over 2. So I'm gonna put 1, 5 over 2. And again, you can probably do that with way less work than what I just did, and then do the other diagonal midpoint. Do AC. So A, of course, I'm just looking up there, was the negative 3, 3. You got your C. And I'm gonna midpoint formula these. So I'm gonna add the x's, 2 over 2 again. Got it. 3 plus 2. And we end up with the same midpoint. So it just depends what you like. I think it's equal in total calculations, to be honest. So it's a matter of, are you quicker and you just rather count the slopes of all the sides, cool, or draw on your diagonals and do the midpoints and show that the diagonals meet at the same and they bisect. You pick it, it doesn't matter. I did both, I got carried away. All right, let's do a standardized test problem because, yeah, we love those so much. Let's read this here. The volume of a sphere is given by that formula. R is the radius. Great. Okay, which is the following? We're going to do spheres in here, by the way. Gives the radius of the sphere in terms of the volume. So first, I'm just going to write this formula over here so I have some room to work on it. So the first thing it wants you to do, really, this is very wordy. Which of the following gives the radius? It wants you to solve for r. You want to get the r by itself. You're solving for the radius. So I see a few things on this side with radius, 4/3 pi in the cube. I'm just going to cancel them with inverse operations. So easy. To get rid of 4/3, I'm going to use the reciprocal. But of course I got to do it on the other side. Okay, so here's where I'm down to 3v over 4 equals pi r cubed. Okay? This is just obnoxious because you got so much stuff to cancel. How are you going to get rid of the pi? What gets rid of pi? Divide, I heard it. So I'm going to put a pi down here. We're going to divide that off. Okay? Now again, you probably could do more work. You know, I live for work, so I'm down to 3v. I usually put the number first. I'm going to put 4 pi. And I think I'm pretty dang close to being able to pick out the answer. Because what gets rid of cubing? A cube root, not a square root, a cube root. So you're going to see a little 3 next to it. And I think we can probably pick out the answer, which I'm off the screen. What is your final answer? D. So you just had to go through and solve for R. Wordy for something easy, okay? All right. So, Monday, no notes. Nothing new Monday. We're just going to practice, of course. Tuesday quiz. Hopefully nice, easy quiz. And again, if you're interested at any point, if you're doing that Chapter 9 retake, just let me know. If you want some quizzes, practice problems, let me know. I was going to ask Greg if he wanted a copy of the homework before he left, but then I thought, bye. But I'm sure he'll get it off of Google Classroom.
I'm sure.
Sure.